Hello dear students, in this video what I am going to do is I will show you some more equations in your data handbook which will help you for some other calculations also. Anyway, till now we have followed only a set of equations based upon your design procedure, but that may not be sufficient for you if the question is the data provided is different. So kindly look here. I will be explaining every equations or the useful equations along with the data handbook. So what you have to do is kindly make a note of the equations, where it should be used and how it should be used. Okay. So initially all these equations 14.1a, 14.1b, all these equations we have used for the various calculation. Also we have used the equation for the length of the belt drive, that was also being used. So what I'm going to discuss here is not these equations. Suppose there can be a question wherein which they will give the velocity and they will not give you the center distance. Okay, so if center distance is not provided, you are supposed to assume that. And thing is that if you have the velocity with you, you can use this empirical formula. You can use this empirical formula for the calculation of center distance, provided if you have the velocity. Okay, this is one possibility you have. So you can use this equation also as to find out the center distance if it is not given, because that is an essential data for the calculation of length of the belt drive and also for the calculation of the angle of contact. So C is a very important parameter and it should be available readily before you start the problem, and if it is not provided you can use this equation. Okay, that is one special equation. And second one is the BAT formula. See, it is given over here. This is the BAT formula, and I hope you understand the meaning of this equation. It is nothing but equation used to find the coefficient of friction using the velocity. If nothing is provided, that means not the belt material, the pulley material, nothing is provided, and if you can't use the table number 14 point, which one was that, 14.2a, you can use this equation also, that formula, to find out the coefficient of friction. But only thing is that you should have the velocity with you. If you don't have the velocity, you cannot. So if you have the velocity, you can use this equation to find out the coefficient of friction. That is another useful formula. Okay, now moving forward, I think all these equations we have used. This one also is quite familiar for you. These equations we have used for calculating the power transmitted per square mm. All those things are very common. This also we have used. Now moving forward, what I am going to discuss right now is some different aspect of the design. See, till now our design was focused only on the design of flat belt, right? The cross section of the flat belt, the length of the flat belt, the uh, angle of contact, coefficient of friction, like that we have conducted our design. Nowhere we have discussed about the pulley design, right? So you may be asked to design the pulley also, or you should have the value of the diameter, because I hope all of you remember the step number 1. The step number 1, I have asked you to calculate the diameters. Unless you don't have the diameter with you, you cannot go for the step number 2. So diameter, if it is not provided, what will you do? If sufficient data is not provided in your step number 1, then how will you do? For that you can use these equations. See, Savrin's empirical formula is given over here. What exactly this does? It calculates the diameter of the pulley. See, this is a very important equation, very important equation, this one. Okay, this uses uh, used for the calculation of diameter, smaller diameter of the pulley. So you have 525 minus 630 cube. You can take any value between 525 to 630 cube under the root of p by 2 pi n max. N max is the maximum speed. Nothing. It means n max you will be going for the small n value, because of the two speeds, capital N and small n. You have the maximum speed for the smaller pulley. So use this maximum value of n over there, and you are going to get the value of d. Once you have the value of d, you can directly standardize the value from the table number. I will show you. it is available here. See, now this it's 14.9. Yeah, yes, this one is the normal. Sorry, not this. Nominal diameters on the next page, 313. Yes, this one. Nominal diameters of the cast iron mild steel pulleys. Okay, if you have a value, you can use this particular table for standardizing the value and select a standard value. Here also the table for the width of the well, that I will explain right now. So that table can be used to find out the standard size of the diameter of the pulley. Okay, now to find out the diameter of the larger pulley, you can use this equation, capital D equal to 1 minus epsilon into D into I. This also can be used. Okay, so once you have the value of if you want to calculate the value of D, you should have the value of epsilon. Epsilon is given between 0.01 to 0.03. Usually epsilon is given here as a coefficient of creep, but I have a doubt in that. Anyway, usually the value of 0.01 to 0.03 indicates the value of slip. I hope you remember my first lecture, in that I have told you that the slip is given in percentages like 2%, 3%, like that. So if it is given as 2%, then the value is 0.02. If it is 3%, it's 0.03. That value you have to substitute it here, and capital D is nothing but the value that we have found out just before this, and I is the velocity ratio. So you can use this equation also to find out the diameter, capital D and small d also. Okay, and again that formula is used to find out the width of the pulley. Usually the width of the pulley is always larger than the width of the belt. There will be a higher dimension, but will be definitely higher than that of the breadth. So this is an empirical relation. You can use this equation to find out the width of the pulley. Also the number of arms, you can use these equations. All these equations are pretty straight. Okay, arms means what? These are the arms. Okay, radius R, radius of the cross section of the arms. All those things you can find it out. Okay, so thickness of the arm A1 near to the rim, taper 4 mm per 100 mm. All these data are given. So the reason why I explain all these things is that sometimes the question can be in this manner also. You may be asked to find out some dimension, or they may not ask you. Sometimes they can ask you. If they ask you, you can easily go for it, but you should have the sense that these equations are available in your data handbook. You can use this equation to find out the values. So that is the reason why I have insisted you to go through the data handbook many times. You understand the equation, what are the equations given, how you can utilize that, what are the data that you should have with you to execute this design. That is a basic idea every design person should have in their mind when you use a data handbook. Without understanding the data, you cannot do anything. So these are the equations available in your data handbook, and you can go ahead, you can go for the calculation of ground height. All those things are available. Okay, so kindly make use of all these equations also if it is needed. In a usual design procedure, we will not go for the calculation of this, but these are equations that can be easily done. So you should have an idea about this also. I hope you will remember this, and I will try to give some more questions to practice for the practice. Okay.